Hello, my name is Demian B, and I'm the product manager for IDS, Intuit Design System. And I'm really excited to be here. Let's get started. Pretty much all design system teams are working really hard to make sure the system is solid, cohesive, up-to-date, efficient, well-adopted, and fully accessible. Maybe, just maybe, one day, the design systems we're all building will get to that ideal state. In theory, that ideal state is beautiful, almost magical, similar to the never-ending story dog. Remember the dog? Maybe it's revealing my age. For the ones who haven't seen the movie, it's a beautiful flying magical talking dog or dragon. Sorry to say this, but based on my experience and the experience of many others, this ideal state doesn't exist. It is simply not possible. But teams all over the world, new and mature, continue to aim for that. Something has to change. Why I'm saying this, it's not possible. Let me share a little bit of our reality. Intuit is a 40-year-old company with more than 100 million customers with very strong brands. Each brand was created differently at a different time with a unique design language to solve particular customer problems and business goals. At Intuit, some design languages were created in-house, while others came from acquisitions, such as Credit Karma and more recently, MailChimp. And in the middle of this brand evolution, IDS was born. Intuit Design System started in 2015 on a project called Common Elements, which looked at ecosystem foundations like color, logos, and typography. We changed our name to IDS in 2016 when we added UI components. If creating a single design system is already highly challenging, imagine trying to create a major new parent system. The requirement to support older and newer design languages makes the endeavor 10 times harder. Just to give you an idea, today, in 2022, if we focus only on designers, we have more than 80 published Figma libraries to support multiple systems, such as QBDS for QuickBooks or CGDS for TurboTax and Mint. And we're only talking design. We're not even mentioning code, which represents a huge critical portion of any solid design system. Well, with all this complexity, how could IDS bring a unified design language to life? Let me tell you what we did. First, we needed to clarify who our IDS customers were. We needed to make sure it was very clear to everyone on the IDS team who is the person our product would work for. In the case of our Intuit Design System, our customers are Intuit designers and Intuit developers working in our business units. It's the product designer working on Mint workflows. It's the web developer working on QuickBooks UI development. And if we look deeper across business units, we can see these internal product designers, marketing designers, web and mobile developers where they are. We can see the size of our market. Once we defined who our IDS customers were, we ran and continue to run multiple qualitative and quantitative research to come up with a list of prioritized problems for each audience. Both internal designers and internal developers share the same challenge of finding the correct information to do their jobs. There are too many design sources. There are too many code sources. Which one is the right one? Our customers face analysis paralysis. Even worse, if they can move forward with what they have, they create new ones, adding more noise to the chaos. But what could we do to get into a better scenario? We decided to change our design system approach. Instead of enforcing the system or creating components expecting that business units would just use them, we decided to focus more on serving our internal designers and internal developers. With more data on the problems to solve, we decided to invest in tooling and infrastructure to accelerate their workflows, reducing their time to value. As a team, we continue to provide qualitative guidance and invested energy in bug fixes. To be more efficient, we created squads and started running unified grooming sessions so that everyone would be aware of the work being done. Making progress became more important than having the perfect Figma library. We shipped more often, ran QA sessions, and worked on incremental improvements. Our design system team, through our product, should do all the hard work to help our designers and developers succeed. And if we do it right, designers in Figma get the best Figma artifacts with variants, and developers get the best packages with transformed platform-specific tokens for their projects. And lastly, and probably the biggest decision, we decided to meet our customers where they were. For instance, instead of forcing internal designers to visit our IDS website for design system data, we decided to meet them in Figma via a brand new plugin. So let's take a look at the Intuit Design System Figma plugin in action. So first I have Kelsey, a product designer, and she's looking for a modal dialog component for TurboTax. Let's have a look. So before the plugin, she used normally go to the Assets panel there on the left and search for modal dialog. And because we have so many libraries enabled, it becomes really impossible, nearly impossible to find the right component. And she needs that BU specific, that TurboTax. Even if she adds TurboTax to the search, things still are very, very messy. Very hard to find the right information. So what we did is she can click on that Intuit Design System plugin, see all the components that are available, get to the modal dialog component, see the details, switch the BU to TurboTax. We use tokens to change theming right there. See all the variants, get the right one, and simply drag and drop that component and make all the necessary changes there, remove the things that are not needed, bring the right copy, and boom. She has the themed component to TurboTax, much, much faster. Now let's look at Code Solano, a senior product designer looking for icons for Mint. Let's have a look. So here, Coates has a lot of icons needed for this project. He can go to the Icons tab on the plugin, search for the first one, which is food, get to the details of that icon, switch the theme again to Mint. And again, using tokens, we're making all the necessary theming changes. And with just one move, he can drag and drop the right component to canvas. You can go back and search for more. And we're using fuzzy search and tagging to help with the search. And he can even see links to developer workflows down there so he can stay more confident as he makes his choices. And the last one is, and all these assets are real Figma artifacts with the right variants and everything, so they can continue to work in Figma using its full potential. And last, let's look at PJ here, a visual design strategist, looking for color, a button, and a storybook link for her developers. Let's have a look. So as she launches the plugin, you can see the theme is already set, so she doesn't have to set that again. She can go to the Colors tab, go to the right color there, and with one click, she can apply that color to that bar. Now she needs a button component, and from anywhere in the plugin, she just selects that asset and drags to the canvas. It is super native to Figma, so she can update the label, make the necessary changes there. And if she needs to find information about specific components that the plugin can recognize, she just clicks on it, and then the plugin changes to show you that, including, in this case, that storybook link that she needs to share with her developers. So that's the current state of our plugin. Now, I'll hand it off to Kelly to show you how we got there.
Thanks, Demian. Hi, everyone. I'm Kelly Harrop, the UX engineering lead for the Intuit Design System. In addition to serving our designers and developers, we wanted to solve a few pain points for the folks who work on our design system teams. For our designers, we typically support a few foundational and component Figma libraries. And for developers, we typically support a few code repos based on their tech stack or their project scope. So what's the big deal? Okay, maybe it's more than a few design libraries. And maybe it's more than a few code repos. But that's okay, because we all know that everyone's making the right updates in the right place at the right time, right? Well, unfortunately, that's not always the case. With so many different areas to maintain, it's easy for things to become out of sync and honestly chaotic. And as a small team, how do we ensure that all these changes are happening correctly across multiple different areas? Well, the first step for our team was to figure out how we wanted to connect design with code. Maybe we could use Figma to generate code, or maybe we could use code to generate Figma components. But we were worried that design assets built from code would be a potential compromise for designers. And likewise, code built directly from designs could be a compromise for developers. So we went with a third approach to establish a centralized source of truth that would allow us to give designers the best design assets and developers the best code assets. And we called this centralized solution design data. Now, what do I mean by design data? Our team started small with just thinking of design tokens as design data. And as we progressed, we started adding variants, documentation, asset mapping, code snippets, and more. Essentially anything we wanted to add to our system, we added it to design data. And now with our centralized data source, we could optimize our process even further. Since our design teams all use Figma, we could reduce some duplication here by setting one library as our design source for our Figma plugin, which means now we can use design data to connect a single design library with multiple code assets. So how can we apply design data to make changes across multiple different places? Well, let's take a look at everyone's favorite component, the button. But wait a minute, I'm getting a request that we need to make a few changes. Okay, that's not so bad. We just need to go in and update the corner radius to support this new pill shape, and oh, the other products need this update too. So how can we store these changes into something that can scale for these different systems? We started looking at an existing model, CSS. Taking some lessons from how CSS handles inheritance and cascading styling rules, we wanted to leverage similar logic for how we store design data. So we established what we call a parent theme. With a goal of consolidating into one centralized system, we have this parent theme, which allows us to reduce duplication in all of our themes' data, and it allows us to adopt a default look and feel that cascades throughout the other products. We can also use this cascade model to help us think through the relationships between all of our different components' variants, like these primary, secondary, and tertiary buttons. By establishing a base variant, we can apply this data throughout all the other variants and use it as a common thread. And if there's a theme that can't take on our new pill-shaped refresh, that's not a problem. We can define those custom overrides and showcase them in our plugin too. And voila, product designers and developers get the assets they need to be productive, and the folks maintaining these systems get some much needed relief. And now I'll hand it over to Kelvin, who will talk about how we built this design data system and how it powers our Figma plugin.
Thanks, Kelly. Hi, everyone. My name is Kelvin, and I am the engineering manager for the Intuit Design System's web team. As Kelly mentioned, we built this design data system in order to encompass all of our design decisions. And this very system is a system, an engine that powers our plugin. But what data is it actually providing? To explain that, let's first set the scene. Let's say we had a designer that needed to use a button component and wanted to see what options were available to them. To do this, they could just load up the plugin, and then they can see all the details about it. The plugin can provide information such as a description of how to use it, showcases possible variants, and even provide links to a playground where they can play around with this coded component. Some of this data comes from Figma, and some of this data comes from the coded component. But how do we pull all this data to then show in the plugin? And more importantly, how do we actually map that designed Figma asset with its coded counterpart? Well, all this information was made possible by the design data that we talked about. Because it acts as our source of truth, it provides the relevant data needed to render the plugin experience that you see here. So with that context set, we can now address the following question. How did we build our design data to map our Figma assets to their coded components? To explain how we do this, I would like to introduce you to the developer portal. What is that? Well, the developer portal is an internal web tool here at Intuit that acts as a central hub for any technologist to build anything. In layman's terms, it's effectively a web tool that lets you scaffold any software feature in a few clicks with the UI wizard. So whether you're trying to launch a mobile app, provision cloud infrastructure, implement serverless functions, or even create a new component library, all of these can be scaffolded for you through this user interface on the portal. So for example, if a developer wanted to create a brand new React component, all they would need to do is select this asset they like to create, in this case, the component. This opens the wizard, which allows the developer to fill in any metadata or pieces of information they want about what they're building. Then voila, a unique ID is assigned, and they get a brand new software asset that comes with everything they need. This includes continuous integration and continuous deployment pipelines, production and QA environments, telemetry data, etc. So with that introduction out of the way, how does this actually help us map our coded component with their Figma assets so that we get the data that we need? One of the critical features of the developer portal is that for any asset that gets created, its metadata is uploaded into something called the data lake. The data lake is a storage repository that can hold a vast amount of raw data. And then we can use that data for analytics or even query to pull any relevant information. So no matter what type of software asset you create, all of its important metadata gets uploaded to the data lake. So for example, the software asset we created earlier was a React component. When that was created as part of the developer portal creation process, that component was automatically assigned a unique identifier. Then all of its metadata was automatically registered into the data lake against that ID. Metadata can include things such as its latest release version, the source code repo, storybook reference, and other forms of data. Now, if we ever need to retrieve data about this component, we could simply query it against a data lake with its ID. And on the Figma side of the coin, we know that Figma uses node IDs to identify its component nodes. So to map our coded component with its Figma asset counterpart, all we need to do is store a literal mapping between the two. And to store this link, we have a custom registration process, which ultimately persists this linking to our custom database that we manage. Then to access this information whenever we need to, we wrote custom APIs that not only pulls this linked data, but can also query the data lake in real time so we can get the latest information for our component. And if we wanted to, we could even store additional metadata information such as code snippets, tokens, and more. Finally, our Figma plugin interacts with these APIs to get the latest information to show our designers in real time. This end-to-end solution is ultimately our design data system. And as you can probably guess, each layer in the system was also generated using the developer portal web tool that I talked about earlier. So now with the design data system complete, all that's left is to build the actual plugin. In order to build this Figma plugin, there are many resources you can learn from, but we primarily use Figma's official plugin docs. It provided all the information we needed and even gave us documentation on how to integrate with their native APIs. But as we were laying out the foundation for building this plugin, our team came upon the following realization. Why restrict this plugin to just designers? Could we also open this up to developers and help them tame multiple design systems too? As Demian mentioned earlier, designers aren't the only ones who have difficulty finding the right assets. Developers also need to find the best coded components that they can use. So why not open the same plugin up to them? This meant we needed to build a solution that could not only run in Figma, but could potentially also run in any environment that our developers were most comfortable with such as VS Code. So to do that, we needed to be bold and innovative. And the solution we came up with was an IFrame. While I can probably hear your moans or giggles, we made the conscious decision to approach this solution with a build once, run anywhere mentality. Because at the end of the day, the Figma plugin that we built is a web app. And it's essentially, what's special about our app is that it dynamically renders any relevant content needed through the power of our design data. So why not leverage the same web app to be adaptable to any environment to serve both our designers and our developers? By using the IFrame, we can make that web app portable enough where it can be adapted into any platform. This lets us render the tailored experience for each appropriate environment, which can get you something like the Figma plugin you've been watching this entire time, or also this VS Code extension, which is themed appropriately for the developer's theme, or even this Android Studio extension. So as you can see, this web app IFrame implementation allows us to build a plugin that can not only run in any environment, but could also be adapted and evolve for various use cases. This, in combination with our design data system, eliminates the fragmented experience that we've experienced in the past. Ultimately, it empowers our product teams to focus and move quickly to innovate for the customers that they are serving and those who use our products. And with that, I will hand it back over to Demian to talk more about what's next.
Thanks, Kelvin. As you can see, our journey to serve our Intuit designers and Intuit developers goes way beyond our Figma plugin. And it doesn't end here. Let me show you what we're planning to do next. Based on feedback from our Intuit designers and Intuit developers, we're planning to invest in expanding the plugin capabilities to support templates and patterns, so that a designer could simply drag and drop a new template that has code mapped to it in our infrastructure and start working. Also, based on feedback, we're planning to create an intelligent chatbot that will drastically speed up our response time as a design system. But why does it matter to you? Well, I'd like to share that we're planning to open source this whole framework of plugins and infrastructure to support any design system out there. So if you're interested, please fill out this short form and we'll reach out to you when you're ready. On behalf of the whole IDS team, thanks for watching, and please stay in touch.